Welcome back, everyone. My name is Daniel Sills, and this is video check-in 6 for the ECE 500 Applied Robotics class at the University of Louisville. And first things first, let me apologize for 3D printer noises in the background. It's just going to be a thing this week. The goal of this class prior to the midterm is to construct an underwater robot capable of submerging in a controlled manner and re-emerging in as well a controlled manner. Using off-the-shelf components and parts constructed through the class. This week's agenda is a motor control overhaul that I've been going over with some components that I received this week, as well as assembly. You can see the picture on the right. So let's dive right into it.
Okay, so I have this 8.5 volt nickel metal hydride battery running through here, and this is a motor controller board on an Arduino. It's a motor controller shield with 4 DC motor outputs. This came in a kit of Arduino stuff that I had at home that I completely forgot about, and it has been a lifesaver. I have these 2 pump motors running in their 3D printed pump mounts, and so they are ready to be mounted into their enclosures. It all packaged up. It ends up in its own little tube about like this. You have the inlet and outlet. These will be sealed. Okay, so using the 3D printed components that I showed off a couple weeks ago, I have now used zip ties to fully assemble the ballast tanks to the central body. And I'm gonna do a float test right now. So this would essentially mimic worst case scenario. If all of the components that ended up on the inside of here were heavier, equivalent or heavier than the amount of water that this entire system displaces, then that's what this is mimicking. So the ballast tanks will be empty for this test, and so this will test if these have enough air volume in them in order to allow this system to float. If that is the case, then we should be good to go on the ballast system working. Okay, so we don't need the tub all the way full for this, so I have it adequately full, I think. Put it in. We have water in the front. Go ahead and try and tip that down. Oh yeah, she's trying to float. Is she? Now I'm confused. Yeah, I think so. Yeah. Yeah, that's definitely trying to float. Yeah. It's like almost neutral. That's funny.
All right, and for future work to wrap us up this week, I'm going to work on finishing the assembly. So I need to seal the motor housings and get the wire so that it is not the primary point of water entry. And then I need to construct the inner chassis for the main body. At the moment, if I were to construct the main body, it would be just dumping all of the components into a giant tube. So that's not good. And then we need to work on plumbing the pump and ballast together, which should not be a big deal, and then consider changes for the center of gravity. I have a thought, but there's a chance with my ballast tanks being low, my center of gravity will be quite strange, although it will allow the robot to come out of the water more. We'll talk about it more next week. All right. Hope you have a good one.